Microsoft is delighted to be at PyCon. Hope you are enjoying the sessions. Scan the QR code to join the Microsoft developer community and receive regular updates on many open source topics, including Python.
Good morning, everyone. Welcome to PyCon APEX 2020. Before the talk starts, just a gentle reminder to everyone that you can post your questions in the live chat. Our next speaker is Joao Bilhim from Microsoft. Joao is a self-appointed data maniac and has been working on applying data to solve complex problems for over 20 years. Joao is currently passionate about machine learning, Python, and AI. During the day, Joao leads the Artificial Intelligence and Machine Learning Specialist team for Asia at Microsoft, and in his spare time, Joao loves to put to work new data techniques and principles to his off-work passions. Joao hails from Portugal, joined Microsoft in 2006, and has worked in the Middle East, Africa, and Asia for the past 10 years. Now, I will pass the mic to Joao.
Hello, everyone. Good morning, and welcome to the Manage Your Data Science Pipeline with Python and Visual Studio Code session. My name is Joao Bilhim, and it's my pleasure to be here with you today. You can follow the session's contents, and you can get them, download them from GitHub, from that URL that you see on the screen. I'm not very active on Twitter, but if you do want to reach out on Twitter, you can find my Twitter handle, my GitHub, and LinkedIn contents there. The agenda for the session today is as follows. We'll start by looking into Visual Studio Code for Python. We'll look at the latest updates, and we'll look at both Visual Studio Code and the Python extension. We'll then do a quick demo around the things that we discussed. After that, we'll look at the Azure Machine Learning Service and how it can be used to help you build, deploy, and train data science and machine learning models. We're going to look at the service itself, at the Python SDK, and at the Visual Code extension for Azure Machine Learning. We'll then wrap up with a series of 3 demos that will tie together everything that we've learned up until now. Now, let's start first with Visual Studio Code. Visual Studio Code is a free cross-platform open source lightweight IDE. It comes out of the box with built-in support for several languages like HTML, CSS, TypeScript, JavaScript. It includes intelligence, debugging, and source control. One of the things that I find really, really interesting is that it provides a rich extension ecosystem, meaning that you can, and we will see this on the demos, you can just open up the extension panel, search for the extension for the language that you want to look into, and you can download and install immediately an extension that provides full-on support for that language, again, including IntelliSense, debugging, and all the extra features that your language will support. We're going to see this in the context of Python, which is really, really cool. Now, nowadays, Visual Studio Code, according to the Stack Overflow survey, is the most popular IDE among developers and SRE professionals across the world. When we look at specifically at the Python extension, which is what we are here to do today, we want to look at one of the most, right now, currently the most downloaded and popular extension on Visual Studio Code. Python and Python extension and Visual Studio Code are the second most popular IDE for, obviously, Pythonistas as ourselves. And obviously, as previously mentioned, through this extension, we'll get full Python support for IntelliSense, debugging, linting, testing, refactoring, but also, as we will see, support for Jupyter Notebooks within the IDE. Now, going a little bit deeper into data science within Python in Visual Studio Code, there are several interesting things that we're going to discuss today, and those tend to focus primarily on Jupyter Notebooks, which is the core of what we're going to talk about today. So, in a way, by bringing together the power of Jupyter Notebooks and Visual Studio Code, you get the best of an IDE, again, source control, collaboration, with the best of the Jupyter Notebook interface that we are so commonly used to working with. Now, obviously, through this, you can edit the IPyNB, the notebook files, directly inside Visual Studio Code. You can convert Jupyter Notebooks into Python files for instance, for production, if you want to productize the code that you've built on the Jupyter Notebook, you can connect both to locally running Jupyter Notebook servers, or you can connect to remote Jupyter Notebook servers. You can visualize the data sets or the data frames that you're looking at in a UI, and you can also look at the plots that you are drawing through, for instance, Matplotlib within the Visual Studio Code interface also. It has an interactive Python console integrated into the IDE, Variable Explorer, obviously, as I mentioned before, full IntelliSense, and ability to debug Jupyter Notebook cells. Now, we're going to look at our very first demo today. In this demo, we're going to look a little bit deeper into Visual Studio Code. We're going to open up the Visual Studio Code. We're going to install the Python extension. We're going to do a quick hello world. And then we're going to do an intro into notebooks in the context of Visual Studio Code. So let's start Visual Studio. You can start by just pressing here. So I'm going to open a folder. Visual Studio Code has the concept of workspace, which can contain multiple projects, let's call it like that, or a specific folder. I'm going to just start from scratch by opening an empty folder. As you can see here on the left, you have several icons. The first one is the Explorer. I don't have any files within this folder, so it's empty. The first thing we would need to do if you wanted to use Python would be to install the extension for Python. By doing that, I would just have to go to the extensions menu, type Python, and you'll see the first result popping up would be the Python extension. It's already installed, so I don't need to install it right now. But if you hadn't, you just had to click install, and it would be immediately available to you. Now, I'm going to create just a new file. I'm going to start from scratch. I'm going to do pycon.py. You can see immediately it detected it's a Python file. One of the things you might not have noticed is that here down at the base, it picked the interpreter. So basically the environment for running Python. If I click here, I can choose between all the different environments I have. I'm going to pick my PyTorch GPU Conda environment. And I'm just going to do a quick sample here. As you can see, the IntelliSense is present. It gives me hints over what all the functions that I have that I'm using. Let's do a quick hello PyCon 8.2020. Now I can run through Control F5, or I can just hit the run there. It's obviously using the Conda environment that I mentioned here, and we get the quick hello PyCon. Now, one of the things I mentioned, and I'm going to just maximize the window. One of the things I mentioned is that there was interactive Python including in the IDE. To do that, if I just use these tags here, you'll see that immediately this content runs like a cell. And if I click Run Cell here, you will see the interactive Python environment launching. Let's give it a couple more seconds to connect. And there you go. So obviously, as before, I can do import date time, start running, print date time, date today, shift enter, and there you go. So as before, you can see I can have the interactive Python. I can run the cells from here. I can have a very familiar experience when running Python either natively as a file or interactively through the interactive Python console. Now, let's move into notebooks. I want to build a Jupyter notebook, so I can do that by clicking New File and just doing demo.inb, which immediately, as you can see, the little icon changing, you can see it detected as a notebook. Or, and before I go there, give me a second, or the other way I can do that is if I do Control-Shift-P, or if I go to View, Command Palette, on Mac it will be Command-Shift-P, I can just do Python, and I'll see all the different commands that I can run. I have the first one, which is create a new blank Jupyter notebook. And it's going to go in and create a Jupyter notebook interface inside the IDE. So again, it's running, as you can see here, locally. It's running on this Python environment that obviously has Jupyter Notebook installed. And here I can do the same I was doing before. I can do a print. And as you can see, again, IntelliSense also works within the Jupyter Notebook. And here I can do two things. One obviously is the usual control enter that we used to. I can also run it through here, through the play menu. What you'll see here on top, obviously, are the icons you expect to see on the Jupyter Notebook interface. You have the ability to run all cells, restart the kernel, stop the kernel, add one cell underneath, clean all the outputs, and several others that we'll explore a little bit later. One thing I'd like to tell is that there are two modes to the Jupyter Notebook experience. On one hand, you can edit, and you'll see that this little bar here is green. But if you click here, or if you press escape when you're typing, it will go into this command mode. In command mode, you can use the keys, letters, to add things like, for instance, add a cell up below, add a cell above, and so on. You can use the command to add cells below or above the current cell that you have. I'm going to now open a little bit more complex example. Let's go into my Strava example. Now, we're going to explore a Jupyter Notebook. That's a notebook that's a little bit more advanced, just to kind of get a little bit more experience. Again, as you can see, running on my local server, running on my Conda environment that I pick. Now, if you saw some of the intro videos that we put on Twitter around our session, you see that I like running. So I have all of my running data and some swimming and cycling data on Strava, which is, think of it as almost like a Facebook for sports. You can record all of your exercises from whatever device you're using into that platform. The good thing is that obviously it has an API with a couple of Python libraries that allows you to extract and synchronize all your runs. But you can also obtain your exercises or your activities through downloading through your profile. So this is what I did. I just downloaded my profile data, my activities, and we're going to just take a quick look at that data. I'm going to start first by importing libraries that I need. I'm going to take a quick look. I'm going to use load the CSV with my activities into a pandas data frame and take a quick look at the five first records. And you can see here you have activities and so on. You have a lot of columns in here. This column, relative effort, is the one that I'm most interested on. It's the column that determines how hard was that exercise for me. We can look at the full column set here. That's where you see things like average speed, distance, max speed, moving time, and so on. Now, I'm going to move into the next usual stage in the data science pipeline, which is to really go in and clean up the data. So I want to pick only relevant columns. Again, I want to predict the relative effort. So I just want to capture the columns that I believe are relevant for this. I don't want descriptions and other things that might not be relevant. I want to keep only runs. I want to drop any NAs and do a calculated column. Now, I'm also going to use this to show something different, which is a debugging experience, which is the run by line. Okay, with run by line, you'll see that I can literally jump through within the cell. I can go and start running one by one each one of these steps. Now I'm picking only the run activities. As you can see, let me just give you a little bit more room. I'm dropping DNAs now. And I'm going to calculate the average speed. What you also notice here is that while I was running, you had the variables explorer up here showing all the data that was being debugged in a way now, which is really powerful and allows us to really go in and check in on the data that we're seeing. One of the other things I'm going to take the time now to show is if you click here, for instance, on runs, you'll go into the data viewer. The data viewer will give me a way to filter the information that's on that data frame. So for instance, if I want to, so you see again, that's the filtered data frame that I built. I can go in and say I only want morning runs. I only want if the elapsed time is above 5,000. And you'll see that very quickly I can look at the outliers and do really quick filtering on the data frame that I have visually and interactively without having to leave Visual Studio Code or without having to build any custom code for that. I'm going to hide the variables, which is you can always bring them up through this icon there. Now let's look at the data. Again, this is just a quick view. I have 351 activities. This is the average effort and so on. Sorry, the mean effort. Now, quick look at the data frame again. Let's make sure we have everything we want. 10 columns, and we're good. I still have a couple of descriptive columns. It's okay. Now, I'm going to use Seaborn to plot the distribution of the metric that I would try to predict, which is the relative effort. And then you'll see, obviously, I had here a mean of around 90, I believe, and 91, and you'll see that it kind of tends to be around that. Now, the next thing I'm going to do is I just want to plot all of my runs over time. So basically, the first thing I do, I prepare a calendar to make sure I have the gaps, the days I didn't run. they show 0. So real quick there, this is the runs over the last couple of years that I've done. But this is day by day, so I would like to see this aggregated by month. So I can just do a quick aggregation on the months. And obviously what I see here is you can see the big spikes where usually when I run a half marathon or a marathon that month. That's where usually I tend to have the big spikes. You can see the places where unfortunately I was injured, and you can also see some vacations where I didn't run. Shame on me. Now, if I click here, you'll see something different, which is the plot viewer. Okay, here you can actually go and zoom, save the data for each one of the plots that you see on the small window. Again, the plot viewer is also an interesting way to look at this. Now, last but not least, I'm going to look into correlations. I'm going to try to see, I'm going to do a correlation metrics to see which variables matter the most or influence the most the relative effort metric. So again, this is the one I would like to predict, relative effort. And as you can see, the amount of time I spend running, the distance that I run, and the average heart rate are really the most important factors determining my relative effort. Okay. And with this in mind, I could just build a smaller data set just containing those 3 columns plus the relative effort, and just give a quick distribution. In this particular sample, I'm not going to go the next step, which would be to build probably a non-linear model to calculate the relative effort. But you can just see a quick example of how the distribution for these 4 variables looks like in terms of correlation between each other. Now, one thing I wanted to show is if you just click this button and you export to Python, you will immediately get all of this code in a Py file immediately. So if you want to take it to production, immediately it's ready for you to take and just hand it out somewhere else. Another very interesting thing that you can do here is, for instance, let's say I only wanted to generate this particular chart. What I can do is come here, use the gather experience, or the gather option, I should say. And you will get a smaller Jupyter notebook with just the core things you need to run that. You see, I removed everything. It automatically removed everything else. Let me just do a quick save here. Demo. And if I run all, you'll see it runs, and it basically has the minimalistic features that you need in order to run just that output that you wanted, which was the correlation between all the different variables within the run. Okay, so that's it for I'm just going to check if we have any questions. And if you have any questions or if you want anything to ask me, let me know. I'm going to close these 2 icons and I'm going to go back to our PowerPoint. Now, we're going to talk a little bit now about Azure Machine Learning in this section. So think of Azure Machine Learning as the cloud service that allows you to manage in a collaborative way your data science and machine learning pipeline by providing a set of capabilities and tools that allow you to build, train, and deploy models faster and more effectively. Now, when I mean by faster and more effectively, we're talking productivity, data scientist productivity, but we're also talking about providing the right tool for the right skill. We don't want to force anyone to use different tools that they are not used to. We want to provide the best tool for each person's skills and preferences based on what they want to achieve. Okay, so if you look at this spectrum, which shows a preference from no code to with code, a preference from beginner analyst to analyst pros, think of the vertical axis almost like a level of familiarity with data science and machine learning. On the top left, you'll have people that are data scientists, but they don't prefer to code. Okay, so there's a visual designer in which you can do all the data managing, build your models, deploy your models, train your models, and deploy your models, all using a UI. On the same axis of lower preference to code, if you actually don't know a lot even about ML, you can use the automated machine learning UI, where you just provide the data set, and it will run a batch series of models, different models, including ensemble models, and it will give you the best performing model for the data that you had. Now, on the other side, with a preference for code, on the bottom, if you're a beginner, you can use, again, still the automated machine learning UI with the SDK. You can use our AI cognitive services, or obviously you can start getting your feet and hands wet with notebooks and Visual Studio Code. Now, today, we're going to focus up here. We're going to focus from now onwards on the next demos on the Python SDK for Azure Machine Learning, and we're going to focus on notebooks and VS Code. Now, in terms of MLOps, we talked, obviously, the Azure Machine Learning is an overarching platform, as I described, but we obviously want to make sure that we provide the right tools and the right capabilities to integrate data science and machine learning pipelines into your existing DevOps pipelines that your organization works, or if you don't, help you create a new set of MLOps processes and technologies that allows you to fully manage your machine learning lifecycle. What does it mean to manage an end-to-end machine learning lifecycle? Anything from dataset management, versioning, to model training, model management, model serving, and eventually even beyond that. Because if you do dataset management, at the same time, at the end, you can do drift management, and that drift management will trigger model retrainment. Now, when we talk about open and interoperable, we really talk about providing you language support for not just Python, but R, providing you support for the frameworks that are more common, like PyTorch, TensorFlow, scikit-learn, Keras, Chainer, but also providing you support for an industry initiative that Microsoft and a lot of other partners have been working on called ONNX, Open Neural Network Exchange, which allows for a lot of these models to be built and interchanged and create a certain framework-independent approach to deployment and inference and training. Now, obviously, on the development tool side, today we're talking Visual Studio Code, but there's nothing that keeps you locked in Visual Studio Code. You can use whatever UI is the one that you like the most. Last but not least, there's a lot of focus recently on responsible ML. So through the Azure Machine Learning Service, you can obviously have the right support for understanding models through interpretability and fairness frameworks. You can use differential privacy and white noise in confidential compute to protect the data and protect the type of information you share. And at the same time, you can control the data through audit trails and data sheets. Now, I'm going to talk about a couple of concepts that will be relevant, I believe. So I'm going to just spend a couple of seconds explaining some of the Azure ML artifacts or Azure Machine Learning Service artifacts. You can look at the workspace as the Uber container, the big container for all the different content that you'll have inside your Azure Machine Learning space. The contents that you'll have inside the workspace will be things like experiments, which will track the runs that you do of your models. It will have data set, which is obviously a connection to your original data that you will version. It will have the compute targets that you'll use for training, for inference, for batch, and also for as your development VM if you choose so. It will have environments which define how that that specific training job or that specific inference job, all the dependencies that it has to create a container image that then gets deployed on the compute target. Again, images we spoke a little bit about. Pipelines. Imagine a scenario where you have your obviously doing the model building, then you're training, then you're doing hyperparameter tuning, then you're picking the best model, then you're deploying on a web service. You can chain all of these different tasks into a pipeline. Deployment, obviously deployment on containers, on the edge, on an AKS cluster, and obviously the models themselves. Now, one of the things we're going to talk a little bit about is or we're going to show throughout the next set of demos is the Azure Machine Learning extension for Visual Studio Code. So again, the purpose of the session today is to do everything inside Visual Studio Code. So build the whole pipeline in Visual Studio Code. So one of the things we're also going to show is this extension that exists inside Visual Studio Code. It allows you to obviously manage the workspace that we talked before, submit experiments, register models and services, view existing pipelines, and connect to remote servers. Now we're going to go through a set of 3 demos, okay? And the 3 demos, the objective is to walk through building a model on the local machine, which is this device I'm currently using. Then we're going to look into building a model on what's called a compute instance, and I'll explain that. And last but not least, we're going to deploy and run the model on a set of compute training clusters. Now, the model that we're going to build is a durian versus jackfruit classifier, okay? I'm always mixing up both of them. I think they're really easy by now. I think I can tell the difference, but I don't think I could before I did this demo. So let's see how it goes. Again, the demo will, based on an image, will let us know whether it thinks it's a jackfruit or a durian. And it doesn't know how to smell it, so it only has to rely on what it can see. Now, the first demo is going to be on my local machine. The data is local on the machine. The notebook server is running on the local machine, and obviously the training, the compute will be on the local machine. So let me switch to my Visual Studio Code. I'm going to close this. I'm going to open the first IPNB. And this first version does not rely on the Azure Machine Learning SDK, so you can run this anywhere you want. Again, it's 2 classifier, 2 classes, durian versus jackfruit. It's going to use, I built it using PyTorch. Whoops, sorry. And I'm going to use transfer learning. I have a small set of data. I can show you the data. The data is here on this folder. If I look at the train, you'll see I have 2 classes, durian and jackfruit. If I look at the durian class for training, I only have 43 samples. So you can see it's a very small data set. So in order to be able to, with a small data set, to achieve high accuracy, I'm going to do transfer learning by taking a ResNet 18 neural net model. I'm going to take the last layer and just train the last layer with those 43 samples of durian and another 43 samples of jackfruit. And again, as I said, local compute and local. Good. I have a couple of questions, and I'm going to. Yes, Mr. Valdez, the question was, do we need to install Notebook before we use it in Visual Studio Code? Yes, let me go back. See what ends up happening if it detects that you don't have a Notebook server, and it will open the command line, and it will ask you to basically just do a conda or a pip install of the Jupyter Notebook on that environment that you have. And so the actual Visual Studio Code, when it detects it misses a specific package, it will trigger you to install that package, or it will install immediately, ask you for permission to install immediately. Same thing applies for things like linting. If it doesn't have PyLint on that specific environment, it will tell you, look, you're trying to run a Py file, I don't have linting enabled, do you want to install? And obviously it checks that for the current environment that you have running. Again, as you can see, local server and my PyTorch GPU environment. Good question. Thank you. Keep the questions coming. Now, I'm going to start as before, I'm going to just start by importing all the variables that I have. I'm going to, import all the packages that I need, the variables that I'm going to use. So basically whether the image is color or RGB, color of black and white, the number of epochs, so the number of full passes on the data set that I want to train the model on, my learning rate, step size, gamma. You have a little bit of details what those means, but they are related to basically how the gradient descent, because we're going to use a stochastic gradient descent, how the parameters for that are going to be set up. The next thing you'll see is that I'm picking a device. With PyTorch, I can tell it specifically to use CUDA. My laptop has a GeForce video card, so I can use CUDA. So next thing we're going to do is we're going to load the data set. We're going to use the Python data loader, which is a really easy way to load of our data. Immediately, the data will be loaded in 3 different data sets. One of them is going to be train, the other one is going to be validation, the other one is going to be test. We're going to train using the train data, validate each pass through the validation and data set, and then in the end, we'll just have this previously unseen test data set that we can use to just do some final tests. I'm going to load this data. Again, the data is local. It's 2 classes, durian and jackfruit. I'm just going to take a peek at the data. So quick look at the data, see how it is. Okay, there you go. Durian, jackfruit. Okay. Now, this is where I have my classifier. I'm not going to go into detail. This is just the helper function to do the training itself. It's going to iterate through all the epochs, and it's basically going to do the training, and in the end, it's going to save the model as a PT file. Save this. Now, this is where this is where the training gets done. So again, as I said before, we're going to take a model, ResNet 18. If you don't have the PyTorch ResNet 18 installed, it will download as part of this execution. I'm just for you to make sure you believe in me, I'm going to show that this is going to run on my GPU. So just give me a second. And we should see a spike on the CUDA GPU, on CUDA there. Start the training, 2 classes is not going to be, doesn't take a long time. Again, the data set is very small, and you see the CUDA core starting to get busy doing the training. Again, only 2 epochs, so only 2 passes on the data set. Second one, and it's done. Again, like with all good models, it's non-deterministic, so this varies from each run. I hope we have a good model now. Yeah, actually, it achieved 100% accuracy on the validation data set. Okay, good. And you can see that once the training was done, the GPU stopped being used. Now, we're going to do inference. So we want to take that model that we saved as part of this. The last step was to save the model, and we're going to test the model. First, we're going to test against a set of the data, basically the data set that we have on the test folder that we hadn't seen before. So just do a quick run on that. And it's going to show me it's going to predict all the different images on that data set, whether they are durians or jackfruits. There you go. So ground truth, I knew which one. It's in the validation data set, but I actually knew which one they were, and they're right. It's 100% accuracy, so it was pretty accurate. If I just wanted to look at one, or if I just wanted to predict one, you have the code again, all the code on GitHub. If I only wanted to predict one, I could just do this. There's another question saying that when I open the notebook in Visual Studio Code, I have an error with my pandas package. Again, when you're running, and this is a really good, another good question. Thank you, Ming Li. When you're running in the Jupyter Notebook, check it's running local, but also check which environment you're running on. If it gives you an error, it's because you don't have that package installed in this environment. Okay. So if it gives you an error that you don't have pandas, it's because maybe on the environment that you have up there, you don't have pandas. You can change the environment quickly just by clicking there and just picking the right environment that you want. Okay, let's move to something a little bit more a little bit more exciting. Now let's move to the second demo. On the second demo, we're going to start using the Azure Machine Learning Python SDK. We're going to use a remote machine to do all the compute. The data is also going to be on the cloud. So but the only thing is that I'm using the notebook file is on my machine, but all the compute is done remotely. Okay. And the notebook server will also be on the compute instance. This means I can access anywhere. I can use an environment that's predefined for machine learning. I'll just get, before we go, I'll just get that started. Just give me a second. And the reason, save. The reason I say this is that you'll see me changing the kernel, and it takes a little bit while just to change the kernel. Second, compute. Okay, so I'm gonna click here, and I'm gonna change to a remote server. I'm gonna change to this compute instance that I have on the cloud. It's gonna tell me to reload it. It's okay. And while it reloads, I'm going to come back here and explain. So basically, by using a compute instance, I can access anywhere from any device, whether with the Visual Studio Code or on the web, if I want to use the Jupyter interface on the web. The compute instance is going to come pre-configured for AML. So issues like before, like missing packages, will probably be not happening or not configured. If I define a GPU instance, I don't have to configure everything for GPUs because the compute instance is perfectly customizable for the CPU or GPU. And obviously, I can define the size of the instances. So on the cloud, I can say I want a compute instance for machine learning, and I want it like with this amount of memory, this amount of disk space, and so on. Oops, sorry, give me a second. Let's get started. The connection is there, but it didn't pick up the environment yet. So let's run the first connection. It will pick up the remote environment. So what you'll see here is that it's going to show, there you go. It's going to show here the environments, and you're going to see that those are different environments. Those are the environments on my compute instance on Azure. They're not the environments on my local machine anymore. So again, big difference. We're going to use the machine learning SDK on some steps. The same thing, jackfruit versus durian, and we're going to use local compute on the remote instance. So the compute is going to be done on the remote instance, and the data is going to be on Azure. So again, same thing as before. Now you're going to see I actually picked a CPU type of machine on the cloud. This is the first time I'm going to use actually the SDK. I'm going to connect to the SDK here. It's connected to PyCon. I'm going to connect to the remote store. I don't want to copy the data. I want to mount the data. So it's doing a remote mount. Then I'm going to do the same thing I've done before around loading the data. I can just do a quick peek of what's inside. Same thing as before, training the model. No changes there. Same thing as before, training. This time the training is remote, so I'm no longer doing it on my laptop. And if I still have time, you'll see me quickly going here before it finishes, and I can show you that there's nothing happened on my CUDA cores. My CUDA cores are sitting quietly as the training goes on. So if you needed proof that I was not running on my local machine, there you go. And then you can do the same thing we did before. Do a quick training on the images that we have. Okay. Now I'm going to do one thing, which is I'm going to reconnect to my local machine before I go to the next step. The next demo that I'm going to show, it's a full-on compute cluster demo. So again, the difference that you'll see is that I'll have distributed computing. So imagine on the first demo, I was doing everything on my local machine. On the second demo, I was just using Visual Studio Code on my machine. All the compute, the data, the execution of the notebook, everything else was in the compute instance. Now, I want to go beyond that because I want to run multiple experiments. I want to be able to scale up and scale down the amount of cluster. I want to be able to submit a large experiment that involves multiple machines. I want to do hyperparameter tuning of my experiment, which means basically I want to be able to tell that if I want to optimize my training for loss, for minimizing loss, and I want you to basically take the learning rate, vary the learning rate by this factor, and just go and run as many tries as you want until you find the best learning rate for my model. And then I want you to pick the best model and deploy. We can do all of these things at scale, almost like a metric search, intelligent metric search. We can do all of this at scale using the compute cluster. Okay, again, compute cluster is going to be on the cloud, data is going to be on the cloud. I'm also going to look into submitting the best model into a container registry, deploying it as a container instance, and then deploying it through a web service API. So now we're going to get the full cycle. Let me go back to my demo. And while the demo opens, one thing I forgot to do, which is I spoke about the Azure Machine Learning extension, but I didn't show it yet. So if you pick Azure Machine Learning, where are you? Here you are. You can install the Azure Machine Learning Python extension. As before, I already have it installed. So I'm going to go straight ahead and show it to you. If you click here on this icon, you'll see give me a second. I don't want to save. You can see all the workspaces that I have. The PyCon 2020 is the workspace I'm talking about here today. And you can see the experiments that we have. You can see the different runs that the experiments have already executed. I think I have 13 runs, pipelines, the models, the endpoints. So pretty much you can do everything you want here, from deploying a model to an endpoint to validating the execution of an experiment, looking at the data. Everything you could do on the UI for machine learning, you can do it here from the extension. Now let's go back to this again. On this sample, you're going to use the SDK to access a remote cluster. The cluster can be a cold cluster, means it starts with 0 and spin ups as many as you need up to a maximum that you define. Or in my case, I already have one machine ready, just to make sure that we do the training faster. So again, connect to the workspace, define the experiment, define the compute target, build the experiment folder. This is the first thing you'll see, the first time you'll see something different, which is I will deploy locally on each cluster. Automatically behind the scenes, it will deploy this training file behind the scenes to each cluster. And basically just doing what we've done before in terms of training, the same thing. Then I'm going to connect to the data store, remote data store. And then what I have here is I'm building an estimator. So basically I'm building the container environment. I'm telling Azure Machine Learning to build a container environment with these dependencies that's going to run that Py file that I built up there. And this will spin off a training schedule. It will run the training on the compute cluster that I define up there, which I can show you here. It's gonna show as a widget here. It's going to show as a widget here, and it's going to start a new run here very soon. I know I'm running out of time, so I'm going to go a little bit quicker. Okay, no worries. As the run goes, you're going to see the run 14 going there. After the run is completed, we can register the model, and it will go into the model registry with a different version. Right now we have 5 versions. Once I register again, we'll have the 6 versions. Now we want to deploy. We want to deploy the model and expose it as for inference. All you have to do is come here, sorry, and build, obviously not a dependency environment, build the Py file that's going to be used for scoring, which is this score Py, which is, and you can check on the, on the GitHub repo, all of these details. So basically initializing the run and then just running the inference piece, which is here. And then this is the piece that deploys that model for inferencing as a web service on Azure Container Instances. Okay, so you see here, I'm deploying it as an Azure Container Instance. I could deploy it to AKS. I could deploy it with a right click on the extension. Last but not least, we're going to just very quickly invoke the web service. So I'm just going to run a couple of helper functions here. I'm going to show you a remote image that I want to run this against, which is that image that we saw before. I'm going to list all the services that we have available. These are all the services. I have 2 services, 2 endpoints. Here are the endpoints. I'm just going to point the image above to that endpoint. Now in here, I'm using the SDK itself. But if you just wanted to, here you go, it says it's a Durian, and that's a probability. If you just wanted to use a normal library, you could just point it to the URI directly, and you'll get the same result, basically. You'll get here the same response. With that, wrapping up today, we saw Visual Studio Code for Python. We saw how we can use Visual Studio Code and the Python extension to explore data, both in a Py file and in a Jupyter Notebook. We looked at Azure Machine Learning and how you can build, deploy, and train models at scale using both the extension and Jupyter Notebooks, using your local machine, compute instance, all a compute cluster, all of that without ever leaving Visual Studio Code. There's a couple of resources there. All of this is available once again on the GitHub link that you see there. If you need any other, if I can help in any other way, don't feel free to reach out, please, and do join our community. Thank you, everyone. Have a great PyCon.
Thank you, Joao, for the wonderful talk. Okay, and then now please stay tuned with us as we will have the lightning talk coming out soon after a short video clip.